Hello. I'd like to talk a little about Note 16, Data Structures Note 16. Those are the bases of your homework 24. What Note 16 is an alternative to the solution to hash collisions, where two different keys hash to the same number. The method we used in Notes 15 was called chaining. And in that case, the item in the table was a pointer to a linked list of all nodes where the key hashed to the same value. And that value was the index in the array. Well, that's one approach. A different approach is not to use linked list. Instead, if we hash something to a value, go to that place in the table and find something else there already, we just move down one place. And if we find something there, we move down another place, and so on until we find an empty place for what we have. Now, that's a reasonable approach. You've got to have a fair amount of room because remember, you're going to be storing every single key in a different place. So you've got to have at least as many as you're reading in, and most of the literature says 2 times as many as you're reading in would be a better way. Now, I just wrote this little algorithm to give you an idea of how to do it. Array H is the same as table H. I just decided to change the name. It just doesn't matter. When I say free, I mean it's no. There's nothing in it yet. So what I'm suggesting is you read the key and the in meaning, just as you did in homework 23, and then you hash the key, the in name, just as you did in homework 23, and then you try to put it in the table. What you're putting in the table is a pointer to a new node which contains the in name and the in meaning of what you read in. And you'll notice here, if it is not null, then I go add 1 to H, and I have to be careful. I might have to go around the circle, around the corner. If H gets to whatever my final number is, the size of my array, I got to go back to the beginning of it. Now, I wrote this program, I think I used 2,000 or so for the code, the hash. I used 4,000 for the size of the table. There's no reason to go that high. It works with 2,000. I did that myself later. I've left a few holes where you're supposed to put in your part of it. And this is the kind of result I got. If you'll notice, there are some large areas where they have a lot of things, and there are some areas where there's nothing. That's not surprising. Now, here's the question. What do we do if we have set up this table and we want to search it? And this also goes for the previous table, the hashing 15. I have a problem that I expect to send out to you shortly, which will set up both of these tables, which you've already done. That's homeworks 23 and 24. All you have to do is put them together. And then you're going to search. I have a file that has some things that are on in the table and some things that aren't in the table. And you're going to look and see if you can find them. Now, I think I may have that already, or some pieces of it. Let me see if it's This doesn't want to come up. I don't know why. There we are. I think, yeah, this is the rough setup of it. I still have to modify it a little. But the idea is, no, that's not it. That was a previous year. That's not it. Let me see if I can find it. I think I'll have to do it in the next one because it doesn't look like I have it handily available. So that's it for now. Work on 24, and I hope those comments I just made help. I used free loosely. I meant that it's null. And when I said array, I just meant table. I just wanted to use a generic name for an array. So see you later. Bye now.